Let's discuss the concept of surface energy. As we know about stretched string, when we talk about a stretched spring, it always stores some potential energy in it. So whenever we talk about an elastic body, if it is an undeformed state, we can say that there is no potential energy in it. But when we talk about its stretched state, whenever we stretch a spring, some work is done and that is stored in form of potential energy in it, which we term as elastic potential energy. Similarly, when we talk about free surface of a liquid, as we have discussed that due to surface tension, the free surface of a liquid also behave like a stretched membrane. So we can say in free surface of liquid also some potential energy is stored in it. And this energy is only stored in the surface of the liquid, which is behaving like a stretched membrane. That's why this potential energy is termed as surface energy. So let's analyze the surface energy mathematically, and to understand the surface energy, let's have an experiment. Say we are given with a U-shaped wire frame on which a slider is placed, and say the length of the slider is L. And in the enclosed part of this U-tube and the slider, we make a soap film. Say for example, we are making a soap film here. Then obviously we can say the soap film will act like a stretched membrane due to its surface tension. And if the soap film is having surface tension T, then this will exert a force on the slider in leftward direction, as on the right side there is no liquid. And on left side of the slider there is a soap film. As the film is having two surfaces, one is above the film and other is below the film. So net force on it, we can simply write force on slider due to surface tension, as this force we can write as twice of TL. As we already discussed that T is the force acting per unit length normal to this, or normal to any line considered in contact with the liquid. So here due to the film there are two surfaces in contact with the slider. So net force on the slider in inward direction will be 2TL. Now if we wish to move the slider in outward direction, we need to apply an external force. And we can say to slowly move the slider out, this external force must be equals to the force which is applied by the surface tension, that is 2TL. And say we displace the slider by a distance delta x in outward direction. So we can say if it is pulled outward by a distance delta x, the surface area of film will also increase. And some work is done by the external force in pulling the slider outward. So whatever work is done by the external force will be stored in the film in form of its surface energy. In the similar way, like if we are having a spring which is already stretched, and if we further stretch it by an external force, then whatever work is done by the external force will be stored in the spring in form of its elastic potential energy. So here we can calculate work done in displacing slider by delta x is this work. Delta W can be written as, actually it will be F external into delta x, and if it is slowly being pulled, in that case F external we can substitute as 2TL delta x. And in this situation, if we talk about its increase in area, we can simply write increase in surface area of film. This delta S, it can be written as twice of L delta x, because as we have discussed, this is a film. So one surface is above the film and other is below the film. So total increase in the surface area of film will be twice of L delta x on one side, L delta x on other side. So here twice L delta x can be written as the increase in area. So here work done can be written as T delta S. And as we already discussed, whatever work is done in pulling the slider by a distance delta x by the external agent, the work will be stored in form of elastic potential energy of the object being stretched, and here the film is being stretched. So the surface of film will store this much amount of work in form of potential energy. So we can write this work as delta U, which we can write as increase in surface energy of film. And in this situation, if we just rearrange this expression, here we can state T we can write as delta U by delta S, which gives us an idea about the numerical value of surface tension as surface energy per unit area, because here the increase in area is delta S and increase in surface energy is delta U. That means this delta U energy is being stored in this much amount of area as the whole film is uniform. So we can write the surface tension as surface energy per unit area. This is another way how we can define surface tension. And let's have some examples based on the concept of surface tension defined as surface energy per unit area. This will be more clear to you.